Now we've built up to the point in this part where I need to talk about when you do a calculation in physical science in this class for the rest of the semester, how are you going to round your number? And I am actually going to hold you accountable for rounding. And say, for instance, a problem's worth 5 points and you don't round correctly, you'll get 4 out of 5 if you get the answer right but don't round correctly. So now these rules I'm going to show you are not just something that Mrs. Snipes made up. These are actually the rules of rounding that carry through the uncertainty through the problem, and I'll kind of show you what that looks like. First off, it depends on what sort of mathematical operation you're doing. So we've got them actually grouped, and I have a proof to kind of show you why this is. But we're going to start with adding and subtracting. Now, we don't do a lot of adding and subtracting in chemistry. We do a little bit, or in physical science. We do multiplying and dividing, and those two go together. But with adding and subtracting, what you're going to do is go ahead and do your addition and subtraction, and then you are going to round according to the fewest decimals. And what I mean to say is, and I'll go ahead and just jump in and do an example. If you have 12.3 centimeters and you're going to add 10.11 centimeters, we would count decimals, and here I've got 1 decimal and here I've got 2 decimals, so I need to round my answer to what? 1 decimal. That's all it is. Okay. I'm going to kind of show you why that is. So say, for instance, we wanted to add these 2 volumes. These volumes were come about using different glasswares with different gradations. The first glassware, the 3.242 milliliters, was probably more expensive than the 26.4 milliliters and had more gradations. So we're going to add those together, and just according to the rule I told you, excuse me, notice that we have 3 decimals here and we have 1 decimal here, and we're always conservative. You can't lie. You can't make it more important than it is. So you have to go with the 1. So that's how we're going to round our answer. But I'll show you why that is. We talked about all measured quantities, including volume. You can relay the number. You're supposed to relay the number in the units. And that last digit, in this case, the digit 2 in the what? Tens, hundreds, thousands place. Okay, that is an uncertain digit. Okay, similarly down here in this 26.4 milliliters, this digit in the tens place, this 4, is also uncertain. So if we line them up and kind of make red hot the uncertain digits, notice that we have this digit's red hot, this digit's red hot, and this digit's red hot in our sum. And remember, again, we can only report to 1 uncertain digit. So it goes back to what I told you a minute ago. We're only allowed 1 decimal, and there it is. And that's why it is. And that will always be the case if your mathematical operation is adding or subtracting. You round according to what I say, decimals, and this is why. So now when I say rounding, you've probably run into this in school prior to this, but if the next digit where you need to drop it is less than 5, this says round down, but really it should be don't round up. Okay, and there's a difference. Don't round up means that you just leave the digit like it is. So actually that's the case here. For instance, I need to allow myself 1 decimal, okay? And so 1 decimal here is, I need to truncate it between the 0.6 and the 0.04. And since this digit right here is less than 5, which is 4 is less than 5, I'm just going to, I'm not going to round up. I'm not going to round my 6 up. So you see that basically we're going to report as our added quantity 29.6 milliliters. Okay, so that's how that works. Is this one stop?